A rope of length L is attached to a support at point C. A person of mass m1 sits on a ledge at position A, holding the other end of the rope so that it is horizontal and taut, as shown. The person then drops off the ledge and swings down on the rope toward position B on a lower ledge where an object of mass m2 is at rest. At position B, the person grabs hold of the object and simultaneously let go of the rope. The person and object then land together in the lake at point D, which is a vertical distance L below position D. Air resistance and the mass of the rope are negligible. Derive expressions for each of the following terms of M1, M2, L, and G.
So I want you guys to interpret this diagram right here. So what's happening?
So the person is going down the rope into the lake, but before he goes into the lake, he's at point B, and then there's an inelastic collision with an object, and they both fall into the lake.
Okay, you're gonna explain to me later how you would determine that was inelastic. So this is the beginning, right? And that's the
Yes,
end. So
yes.
you start from A to B.
Mhm.
So you're gonna have to use the concept of conservation of energy to apply to this concept. So at point A, so I'm just gonna say point A is equal to point B. So now you're gonna apply the energy. So at this one, point A, what types of energy does he have?
He should have potential energy.
Potential energy, which is
That is MGH.
mgh, right?
Yes.
So we're gonna call him. Okay, mgh is equal to, at this point right here, does he have potential energy?
No,
No.
No, because why not?
because the height of reference is right there.
This is the height of reference. So we're gonna say h0, h, right?
Yeah.
So basically the delta h is equal to
L.
L, which is
Yes.
the length of the rope.
Mhm.
So now, at this point you say something that has kinetic energy, right?
Mhm.
So now you're gonna actually substitute. So you're gonna apply. So what's my mass?
Your mass is M1.
Is m1. What's my gravity?
9.81.
Just go ahead and use g.
Oh yes.
What's my height?
Your height
Based on
is
this one.
L.
L.
Which is down. Equal to 1/2. What's my mass again?
M1.
m1, right? What's my
Yes.
velocity?
V.
Okay. And now you're gonna have to figure out how fast the person is actually like traveling.
Yeah.
So from this one, you're gonna have to use the algebra concept to figure out how you would solve for velocity by itself.
Yeah.
So how would you do that?
Well, first you would have to multiply the 1/2 mv squared by 2.
So how
And
about
then-
this? I just get rid of m first.
Yeah, you could do that.
Why?
Because they both have m, since you're dividing
Same.
m.
They're the same masses,
Yeah.
right? So now you were saying something like multiply by 2. So
Yeah.
I'm just gonna go ahead and write it down here. So that would be 2gl is equal to velocity squared.
Yes.
So how do I get rid of the square?
You take the
square
square
root.
root.
Square root both sides of the equation. So now you get that velocity, right?
Yes.
2. So this is a derived equation. So I'm just gonna go ahead and ask you guys to substitute the value in to figure out how fast it's going.
Okay.
The gravity is equal to what? 9.8 meter per second square, right?
Mm-hmm.
Okay.
What's the length?
The
1
length
meter.
is 1 meter.
Let's make it 10. So now you're solving for that velocity.
So,
You're gonna have to do it.
10 times 9.8. That would be 9.89 meters per second squared. No, meters per second for the velocity. Actually, no. 10. It's
It'll be,
actually 14.
14.
So I'm just gonna say substitute, right?
Yeah.
Velocity is equal to 2gl
Mm-hmm.
2. Why am I writing this? What's the answer?
14.
Meter per
Second.
second or second square.
Second, because it's only velocity.
Okay. So now we're gonna use another concept, which is the second one, which is elastic. collision. So I'm just gonna draw this one as the M1. This is M2.
Yes.
So we're gonna use conservation of momentum, right?
Yes.
So can you elaborate on more on what's happening over here, before and after? So we're gonna use this one as a B. I'm gonna make that as a D.
Okay.
Okay, what is delta Y over here? Equal to what?
Delta y is equal to L.
Is L. So now you're gonna use the conservation of momentum. I'm gonna write that. It's over here. So m1 times velocity 1
Yes.
plus
M2 V2
m2 v2.
is equal to
Is equal
M1
to-
plus M2 and then times V.
But why did you say that?
Because it's inelastic and they're moving together.
Okay, where on the paper does it say moving together? Does it say moving together or stick together?
It says that the person grabs hold of the object, so they're moving together.
So right here, they're moving together.
Yeah, because he's grabbing it.
Therefore, it has how many velocity? 1 or 2?
It has one.
1. So I'm just gonna label them as the VF.
Yes.
Can someone explain what P stands for?
Momentum.
Yep.
Momentum, right? Which is equal to
M1.
MV.
mv, mass times
Velocity.
velocity. So now you're gonna have to substitute the value in. So what is our mass?
100 kilograms.
100 kilograms.
So I'm not gonna say 100.
Oh.
Oh, you're doing that.
Yeah, but we don't have.
Okay,
a
you don't
grams.
do that one yet. Can we derive the equation first?
Oh yeah, sure. We're
So
looking for
in this term right here, it refers to mass 2. What happened to that velocity?
that velocity. Oh, V2 is.
V2. What is it, V2? Remember the object itself.
It's at rest, so it's not there.
Yeah, it's not there.
Okay. What's my mass 1? Is m1, right?
Yes.
What's my velocity 1?
14.
It's 14.
Yes. That's what we.
What if
that's-
what if I don't use that number?
Then it's just V.
Then it's V. And what is V?
Velocity.
Which is
2GL.
Yeah, it's
GL.
root 2 GL.
okay. M1, right? Plus M2
Yeah.
times that. Okay, now you need to derive to get that final velocity. How would we do it?
Just divide by M1 plus M2 on both sides.
Okay, M1 plus M2, right?
Mm-hmm.
So that would be VF is equal to
M1 square root 2 GL
2GL.
divided by M1 plus M2.
Go ahead. Now I'm gonna add it. M2 is equal to, what does it say there? No, I'm just gonna give you M2 is 50.
Okay.
So now you figure out the final velocity after the person and the object
Okay, yeah.
when it after collisions.
Sixty-four.
64, yes. Meters per second. Oops, let's see. 100 times 14 and divide by 1. Yeah, it's 9.3.
Yeah, it's 9.3.
9.3 meters per second.
Oh, can you show that on the in front of the camera?
For the oh
Yeah, just make them see somehow.
uh,
Yeah, just like-
give it what? Oh, there it is. Yes. You multiply 10 times
so you
the
get
velocity.
9.33.
Yes, 9.33.
So now for the last part of this thing, we're gonna use kinematic.
Kinetics.
Daniel Crawford, if you're in the building, your mom is waiting on you at the front. Daniel Crawford, if you're in the building, your mom is waiting on you at the front.
So I'm just gonna say as a reference between B and D, right?
Yes.
Okay. You use this equation. Can you see this still?
Yes.
Mhm.
You can still see.
Okay, what is my delta Y?
Your delta Y is
Equals to L.
L,
L.
which is 10 meters.
Okay. I'll put that there later, okay?
Yes.
And what is my initial velocity in the Y direction?
In the Y direction?
Yeah. Remember this one right here? When they stick together, right?
Oh, yeah.
They're not moving up, they're only moving horizontally.
Yeah.
So what happened to that velocity?
So it's not there.
It's not there. But what? You can't just say it's not there.
It's
Is it
zero.
It's zero. Okay, plus 1/2 g t squared. You need to solve for time. How
Mhm.
would you do this on this question?
You already know gravity.
You know gravity, you know
So-
1/2.
You could just isolate T,
How would you do that?
divide by 1/2 G.
No, so
Okay.
you multiply
You multiply by two.
You multiply by 2, and
Divide
then
by-
divide by
Yeah.
G on both sides.
Okay. This right here, right?
Yes.
Yes or no?
Yes.
No. Yes or no?
Looks right.
Mm-mm.
Oh wait,
Wait,
no,
shouldn't
you're
the G
supposed
be
to
on the bottom?
divide.
Yeah, shouldn't the G
You're
be on the
dividing,
bottom?
not multiplying.
So the t itself is supposed to be square root 2LG, right?
Over G,
Yeah.
yes.
So I want you to go ahead and substitute the values.
Okay. Got 1.42 seconds. Alright, yes,
Yeah,
1.42 seconds.
Okay, now for the last part, since we know how long it travels from here to here, right?
Yes.
We need to figure out how far it goes in the x direction. So with that being the case, you're gonna use this formula. Can you still see it?
Yes,
Vox times t.
yes.
So what's my Vox, velocity in x direction?
9.33 meters per second.
Yes, it's this one.
Yeah, 9.33.
And what's my t?
1.42 seconds.
Okay, can you do the math? So you're gonna have to figure out the x distance. Did you get the answer?
Yes,
And that should give you what?
13.32 meters.